Alright, so this is a little introductory video into stoichiometry, basically. Here's the way I want you to think of it. Imagine a pizza recipe. You guys have all had pizza. So if you look right here, imagine you have a recipe that makes two pizzas. So you have some dough, some pepperoni, some sauce, some olives, some mushrooms, and some cheese. Think of it like that. You've all seen recipes before. Well, all you have to do is imagine then a chemical reaction is just like taking that recipe and converting it like that. So 3 doughs, 8 pepperonis, 6 sauce, 2 cans of olives, some mushrooms, and some cheese. You ultimately get 2 pizzas like that right at the end. It's all driven by ratios. You need to combine 3 of these, 8 of those, 6 of those, 2 of those, 2 of those, and 3 of those. And that's all stoichiometry really is combining the ratios. So if you think about it, like here, if I look at this reaction right here, I have C2H4 plus 3O2 plus arrow 2 CO2 plus 2 waters. If you're comparing this to this, because in stoichiometry we only compare 2 things, you could say the ratio, since we use moles in chemistry, we would say 1 mole of C2H4 is equal to 3 moles of O2, or we could say 3 moles of O2 is equal to 1 mole of C2H4. Either way, you basically get a ratio that from one to the other, and all I'm doing is using the coefficient. So I'm taking the coefficient here, taking the coefficient there. It's a 1 to 3 ratio if it's not written, and that's all I'm doing. This would be 2 to 2 if I was comparing those. Now, when we talk about stoichiometry, here's the way you have to look at it. The first thing is you got to look at what your given is. So if you look right here, it says how many moles of NO2. So that's what I'm solving for. So I'm going to put a question mark there because that's what they want. Can be produced from 4.3 moles of N2O5. So that's basically what my given is. You know how to use a grid. So if we go to use a grid, basically we set up a little problem solving grid, and then we're going to do a little chemistry. Now, first thing I'm going to do is I'm going to take my given, and my given is 4.3 moles of N2O5. Now I know using the rules for a factor label I call the fluffy bunny, whatever's here has to match. So automatically I have to write moles of N2O5 here. And if I look, the coefficient for N2O5 is 2. And then what am I comparing it to? My question mark's over here because they told me this was 4.3 moles. So these are the two I'm comparing it to. So I'm basically ignoring oxygen. It's a 2 to 4 ratio. So 2 of these gets me 4 moles of NO2. Cancel, cancel. Then all I have to do is multiply this times this, and then divide by 2. So ultimately this is what my grid looks like. I basically cancel, I'm left with moles of NO2, drop it over there. Units match after my how many, and I'm good to go. Here's the way you got to think about it. Imagine if you go to Publix and you order a turkey sandwich. So here's a little sandwich, a little lettuce, a little tomato, and I have turkey in the center, and then I got the little other part of my sandwich there. In a turkey sandwich, you always have to have turkey. In stoichiometry, the turkey of stoichiometry is going to be the mole ratio. So whenever we have a problem, whenever we have to solve a problem, the turkey is going to be the mole ratio. For anytime you're doing stoichiometry, you have to have turkey. Anytime you have a turkey sandwich or you order a turkey sandwich, it's got to have turkey on there. You're like, what? Let me explain. Here's the way it works. Whenever you have moles in the upper part of the grid, it's time for the turkey, the mole ratio. You get it from here. You basically grab. So at this point, I grab the 2 to 4 ratio, 2 there, 4 there. How did I know I had to grab it? Because moles is in the upper part of the grid. Then I go and get the turkey because in the middle of every turkey sandwich is turkey. In the middle of every stoichiometry problem is the ratio. So if I look at this problem right here, let's look at it here. 4.3 moles of NO2 again. So 4.3 moles of NO2. My question mark is how much O2 am I going to get? So the first thing I'm going to do is I have to do a little problem solving grid. So I'm going to get a grid together. So I'm going to grid it up like this. The next thing I'm going to do is I'm automatically going to copy my given in. So my given is 4.3 moles of N2O5. As soon as I have moles in the upper part of the grid, it's turkey time. It's time for me to drop the turkey in there. In this case, this and that, my mole ratio will be my turkey. So automatically I copy moles N2O5, and then what happens is on the top, moles of O2. Coefficient there is 2. Coefficient there is 1, and I'm good to go. Cancel, cancel. I'm left with moles of O2. What's after the how many moles of O2? And if I look right there, cancel, cancel, moles of O2 goes over here. 4.3 times 1 divided by 2 is going to be 2.2. Now, let's look at a different problem. If you look right here, let's take a look at one of these problems. If I look here, this next problem says how many moles of N2O5, so after the how many, it's moles of N2O5, were used if 210 grams of NO2 were produced. So this is my number I'm given, so I write it on the top. 210 goes there. There's my question mark. So I'm not really paying attention to oxygen. So then the first thing I do is I put 210 grams of NO2 right here. Is it ready for my turkey? No. I have grams of NO there. I have to have moles before I can throw my ratio in. So the first thing I do is I copy grams of NO2 down here. The molar mass of that is going to be 46 is equal to 1 mole of NO2. Now it's time for my turkey. I have moles in the upper part of the grid. Then I go and I grab my ratio. My ratio is going to be, in this case, 4 to 2 because that's what I'm doing. So I know I have moles of NO2, so I have to put moles of NO2 on the bottom. What's the number in front of it? 4. Number that's going to, or the other number that I'm converting to is 2. 2 moles of N2O5. Now I have moles of N2O5 in the upper part of the grid, so what do? Cancel, 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 cancel. They have to match. Multiply across, divide the 2, and ultimately you get the answer. So if you pop it in your calculator, you would get 2.28 moles of N2O5. So I have 210 here, grams of N2 down there, moles, moles, multiply, and then you get your answer. Next problem. If I look here, this problem I'm given 75 grams of O2. So immediately I put 75 grams of O2 goes right there. They're asking me how many grams of N2O5. Well, I have this value and I need that value. I'm going to cancel. I'm going to not pay attention to that. I can ignore that for right now because I'm basically going from here to here. I'm not ready for the turkey right now because I have grams up there. I can put the turkey in or my mole ratio in, which is going to be a 1 to 2 ratio using the coefficients once I get moles in the upper part of my grid. So I go 32 grams of O2 equals 1 mole of O2. Now now I'm ready for the turkey because I got moles up there. So then I go and I grab this. Moles of O2 goes on the bottom. 1 mole of O2 goes on the bottom. 2 moles of N2O5 goes on the top. If I stop there, I get moles of N2O5, but I need grams. So my next step is 1 mole is equal to I think it's 108 grams. Let me see what it is. 108 grams of N2. So if you look right here, what do I have in the middle? I have turkey in the middle. It's like a turkey sandwich. Molar mass with my turkey wedged in the middle. And I get my turkey or I get my mole ratio always from 2 coefficients, the 2 things I'm comparing. Drop it in the center. I got grams. I'm converting here and then spitting it out in grams of N2O. And what am I getting in that one? N2O5. All right. Here's another example. Take a look at it. You can see this one. The problem, it says I have 3.45 grams of aluminum. They want to know how many grams of aluminum chloride can be produced. Well, if I have 3.45 grams of aluminum, I put 3.4 underneath there. That's what they're asking me to solve for, so I don't really care about this or this one right now. The ratio is basically going to be 2 to 2. So when I go and set it up, what do? Well, the first thing I do is I put 3.45 grams of aluminum there. Well, it's not time for the turkey. I need basically grams of aluminum down here. So I put grams of aluminum, 27 grams of aluminum from the periodic table, gets me 1 mole of aluminum. Ding, 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 ding. Once I get moles in the upper part of the grid, then I grab my ratio. I automatically copy moles of aluminum on the bottom. I'm going to moles of AlCl3 on the top. 2 to 2 ratio, bam, 2 to 2. I put my turkey in, and then I check to see if what my how many says. My how many says grams of aluminum. If I stopped right here, I would have grams of aluminum chloride. I would have moles of aluminum chloride. So I had one more conversion factor. Moles of aluminum chloride go down here. 133 grams of aluminum chloride go on the top. Then you just do the math. Let me show you one more here off like your review. Let me see if I can find it. Like here's an example. If you look right here, this is one of the ones off your sheet. You first had to balance. I should have left it there. Let's see here. When I go to balance, it's mg, so it's 2 CO2H. So that should be good. That's a balanced equation. Now, the first thing is, let's do this one. It's the same idea. When you go to solve this problem, it's the exact same idea. I'm going to draw a grid. So the first thing I'm going to do is I'm going to draw a grid because everybody loves a grid. So I'm going to draw a grid here. Bam, bam, bam. And then the next thing I'm going to do is I'm going to take my given. I'm going to put 2.45 times 10 to the 22nd molecules right here. So molecules goes right there of HCl. Do I have moles in the upper part of the grid? No. So then I have to basically have molecules down here. The only conversion factor with molecules in it is Avogadro's number. 6.02 times 10 to the 23rd. Molecules of HCl is going to be equal to 1 mole of HCl. Once I get moles in the upper part of the grid, it's time for the turkey. So who am I comparing? I'm comparing MgCl and HCl. I can ignore this one and ignore this one. So then I have to put whatever's here has to match here. I put moles of HCl down here. Coefficient I grab is 2. The coefficient of that one's going to be 1 MgCl2. Now, what's after the how many? They want grams of MgCl2. So my next step is I have to say 1 mole of MgCl2 because I'm copying. See how it says moles of MgCl there? What's that going to be, like 95? Let's see, 71 plus. Yeah, 94.3 we'll say. Ballpark it. 95.3 grams of MgCl2. Watch. Little turkey in the center. Here I have my molar mass, or I'm going to call it a bun, but I have a molar mass here and a molar mass here. Little turkey in the middle. How do you know it's turkey time? As soon as you have moles in the upper part of the grid, your ratio from the chemical equation gets dropped in. Bam! Boom shakalaka. Let me show you one more. Let me see if I can find one more. Here's an example here. Let me kind of show you. This is already worked out, but this is, I think, from one of your worksheets. If you look right here, they give me 25.6 liters of oxygen. So if I have 25.6 liters of oxygen, right here, automatically I'm not ready for my turkey yet. Can't put the turkey in the sandwich. So what do I have to do? If I have liters here, I have to have liters of oxygen there. So I bust out 22.4 liters of O2. I get moles of O2. Cacao. Bam! I got moles in the upper part of the grid. What time is it? Yeah, that's what I'm talking about. I'm comparing CO2 to O2. So I go up here, O2, CO2. 13 to 8 is my ratio. Well, I start with O2 because that's what I have. I have moles of O2. So if I look right here, I have moles of O2. I have to have moles of O2 right there. That means I'm going to grab the value. I'm going to grab 13, the coefficient. So right there, grab the coefficient. I drop 13 there. I grab the other coefficient. I drop 8 there. And then what happens? I have moles. But what are they asking me for? At the end of the how many did I check? I need molecules. I'm not there yet, which means I have to add on one more piece. So I have moles of CO2 there. I copy 1 mole of CO2. And then I need to take it to molecules. So I bust out Avogadro's number, 6.02 times 10 to the 23rd molecules. CO2, that cancels. And ultimately, I have converted to molecules of CO2. Here's the way you want to think about it. When you have the turkey in the middle, you can have a white bun, a wheat bun, whatever. So basically, I could put in 22.4. It's like you accessorize. You change wherever you're given. You basically drop whatever it is here to convert it to moles, put in your turkey, and then in the end, whatever they're asking you for at the how many, you just drop in there and you're good to go. That's the key thing with stoichiometry. That's the key thing you're thinking about. Like here. Here's a problem where you have 6.3 grams of oxygen. So oxygen's right here, and they want to know what volume of SO2. SO2 is right there. So I first start with 6.3 grams of oxygen. That means I have to have grams of oxygen down there, or O2, molar mass is 32. Then, ding, 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 once I get moles in the upper part of the grid, Then I grab my coefficient there and my coefficient there, which is 1 to 1. Finally, they're asking me volume of SO2. What does that mean I have to put at the end of my grid? I put basically the conversion factor for 22.4 for liters. I drop it in. I make sure it matches. Cancel, 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 cancel. And boom, that's what I'm talking about. Stoichiometry is not that hard. All you have to do is focus on a couple things. You always have to have your turkey. So if you look at the difference in them, look at the difference in some of the problems. Let me see, go back here. Like in the early problems, like here. This problem, if you look here, see how, wait, let me go back to this. These two problems, they gave me moles and they want moles. So that means those are people that don't like carbs. All I do is pop the turkey and I pop the ratio in. I have moles in the upper part of the grid, drop my ratio, basically pop it in, do the math. Same thing here. I have moles and moles. It means turkey, no bread, no bun. Then you look at the other type. You look right here. I have moles and they gave me grams, which means before I can add the turkey in, I go grams to moles, moles in the upper part of the grid. I drop the ratio in there. Boom shakalaka. Finally, the last one is the most common one in chemistry, which is a grams to grams problem. So what do? I take 75 grams, I drop it right there of O2. Not time for the turkey yet. Divide by the molar mass, get moles in the upper part of the grid. Ding, ding, ding. Then I grab my ratio, which is 2 to 1. There I have my turkey. And then finally, I finish with molar mass. All right? Hopefully this helps you guys. Have a good evening. Good luck on your quiz.